Now we're going to talk about rational fractions and we're going to start solving them. But before we do that, we need to learn how to multiply and divide rational fractions, which is tonight, and then we need to learn how to add and subtract rational fractions. So let's start with multiply and divide, which is relatively easy. To multiply and divide rational fractions, you need to simplify them so that there are no factors in the numerator and denominator. They're common. So in this first example right here, these would be called factors. These are multiplied together, A times B, B times C. This is a common factor on the numerator and denominator, so I'm going to cross that common factor out, and I'm going to be left with A over C. Same thing here. I have A times B plus 1 over C times B plus 1. B plus 1 is a common factor in the numerator and the denominator, so I'm going to cancel that out, and I would be left with A over C. Now, over here, I have A plus B over C plus B. B is a common term. It is not a common factor. Okay? I cannot cross that out and make that B over B. Okay? You can't erase those B's. So that would be killing a kitten, and I definitely wouldn't want to do that. So let's simplify this polynomial. I actually, in the numerator, have a cubic, and I have a quadratic in the denominator. The first thing I need to do is I need to factor thoroughly the numerator and the denominator. Remember factoring, this is 4 terms, so the first thing I'm going to try is factor by grouping. So I'm just going to come down here and try to factor this by grouping. That first set has a 2x squared, which would leave me x minus 3. The second group has a 7, which would leave me x minus 3. So the numerator will factor into x minus 3 and 2x squared plus 7. The denominator is the difference of squares, so that will factor as x minus 3, x plus 3. Okay, notice I can cross these two factors out, so my final answer will be 2x squared plus 7 over x plus 3. So let's try this next example. I'm going to multiply this first rational fraction by this second rational fraction. And you know we multiply across the top and across the bottom when I have fractions. And this is going to be really ugly if I decide to try to multiply that out. So the first thing I'm going to do is just factor the numerator and denominator, if I can, so I can cancel out any common factors. So this first guy, I can take out a 4x, which will leave me x minus 1. And in the bottom, that will factor as x plus 3, x minus 1, multiplied by, this is going to be x plus 3, x minus 2, and it's all over 4x. Okay, now if I wanted to, I could multiply the whole top and put all the factors up here. So I have 4x, x minus 1, x plus 3, x minus 2, over x plus 3, x minus 1, 4x. And now I can cancel out common factors. Remember, this is 4 times x minus 1 times x plus 3 times x minus 2 divided by x plus 3 times x minus 1 times 4 times x. This is a factor, 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 factor. I can cross off common factors. Common factor of 4, common factor of x, common factor of x minus 1, common factor of x plus 3. So my final answer here is going to be x minus 2. That is the simplified version. Now, I just want to look back at this original problem right here once we factored it, and I want to remind you a little bit about fractions when you learned them when you were young. If I have 2 over 9 times 3 over 8. Remember, I can cancel 3 goes into 9 3 times, 2 goes into 8 4 times, leaving 1 here. That would multiply to 1 over 12. So I could follow that same rule and cancel the 4 in this fraction over the 4 in that fraction. Common factor in the numerators crossed off the common factors in the denominators. So I still would end up with x minus 2. If you want to multiply across the top and get it in one numerator, multiply across the denominator and get it in one denominator, you can do that. But you can also cross off common factors right from here. Another one. This one you're going to have to remember the difference of cubes. Remember 8x cubed, so we're just going to kind of pull this out a little bit, is actually 2x cubed minus 3 cubed. So my first factor, if I'm going to factor the difference of cubes, is 2x minus 3. And yes, you do need to remember this. 2x minus 3. And then I square the first, change the sign, multiply them, always add, square the last, over 2x minus 3. Now, what you'll have to remember is this put together is a factor of 2x minus 3, and it will cancel with that factor of 2x minus 3. So what I have left in my final answer is 4x squared plus 6x plus 9. Here we go. Let's remember our favorite song. Dividing fractions is easy as pie. Flip the second and multiply. So we're going to rewrite this first as the first fraction times 1 over the second fraction. Flip the second and multiply. So now let's fully factor the numerator. I get x plus 2 over x plus 3 times 1 over x plus 2. We've talked about crossing off common factors. So what I'm left with is in the numerator I have x plus 2. In the denominator I have x plus 3. Okay, this guy is really messy. So we're going to factor as much as we can in numerators and denominators. So in the first numerator, this will factor as 2x and x. And I need 1 in the middle, so 3 times 2. And then we have negative 3 and positive 1. Sorry. And in this denominator, I'm going to take out a 2, and I'm going to get x squared plus 4. I know I cannot factor the sum of squares, so that's all I can do. Divided by, I'm now going to flip. And so the denominator is coming to the numerator. I'm going to take out that common 2. And the numerator is going to go to the denominator, and that's going to be 2x. X. And to get the negative 6 at the end, I need negative 3 here and positive 2 here. So that would be my initial factor, but if I'm looking at this, I see this is the difference of squares, so I've got to keep factoring. So let's cross off what we can at this point. I know that my 2x plus 3 minus 3 factors can cancel, and I know this 2 can cancel. So now I'm going to keep factoring, and the numerator will have x plus 1, but this is the difference of squares, so this will become x squared plus 4, x squared minus 4, all over x squared plus 4, x plus 2. And I see I have another common factor in the numerator and denominator that I can cancel out. But I also notice that this is the difference of squares again. So I'm going to have x plus 1 in the numerator and x minus 2 and x plus 2, and in the denominator I have x plus 2. So the factor of the x plus 2's will now cancel, leaving me my final answer of x plus 1, x minus 2. Can you believe that all of this yuckiness comes down to a simple 2 linear factors? I call these linear because they have a degree 1. This is a linear factor. This right here is called a quadratic factor. Alright, last example, and what I'd love for you to do is pause your video right now and try to work through this on your own. Okay, so the first thing I want you to see is that I factored the numerator and the denominator here. I flipped this guy because dividing fractions is easy as pie. Flip the second and multiply. This is the sum of cubes, which would factor like this. This is the difference of squares, which would factor like this. This very last rational fraction, which has a quadratic in the numerator, linear in the denominator, this actually does not factor, and this will take out a GCF of 2. And I did that wrong, didn't I? So this should actually be a 2 right in here. Okay, so check your work. Now I'm just going to start crossing off common factors. Well, first I can get rid of that trinomial. I can get rid of that x minus 2. I can get rid of this x plus 1. And I think that's all I can get rid of. So I'm going to have 2x plus 3 times x plus 2 over, I'm going to put this 2 in the front. So I'm going to bring this 2 out here in the front. And I have 2x plus 1 over x plus 3. And that would be my final answer. It's really not pretty, but it is simplified quite a bit from this original problem.